Hello everybody, it's Diya, and today we're going to be talking about ionic, covalent, and metallic bonds. So let's get right into it. First up, I'm just going to show you a little review. So on our right here, we see our valence electrons, and a valence electron are the electrons in the outermost shell. And the goal is to have 8 valence electrons. So keeping that in your head, let's go on to ionic bonds. So ionic bonds are formed when you have 2 ions. So first we have our sodium, and our sodium has 1 valence electron. And as a metal, the sodium wants to get rid of it. And so that's exactly what it does, and it gains the positive charge. And our chlorine wants to take that electron because it only has 7 electrons. So we're going to take it and we're going to keep it. And these two, this being a positive charge and this being a negative charge, are going to react together and they're going to combine. So ionic bonds are most commonly found between our metals and our non-metals. So let's get some examples. So here's the same example that I showed you in the past, our sodium and our chlorine. So we have our electron coming over here, and this is a cation because it got rid of the electron and it has a positive charge, and this is an anion because it has a negative charge. So another example of this is sodium fluorine. We have our sodium with our 1 extra and our fluorine with only 7 valence electrons. So it's going to say, give me that valence electron, and it's going to come over here. Our sodium is going to have a positive charge and our fluorine is going to have a negative, and these opposite charges attract each other. Next up, we have covalent bonds. Covalent bond has the same goal as ionic bonds, and that is to get 8 valence electrons. Covalent bonds are usually found between 2 nonmetals. So there's 2 types. There's one where it has the same element, and here we have 2 fluorines with our 7 valence electrons, and instead of transferring any valence electrons, they're going to share them. So they're going to bond together and share these 2. So next step, I'm going to give you some examples. So here we have our water. Water is a great example of a covalent bond. So we see our oxygen with 6 valence electrons, so it needs 2 more. And hydrogen can provide it because they have 1 each. And hydrogen wants to get 2 too, so it's beneficial for both. And they're going to come together and they're going to share these valence electrons. So here, the bunch of dots and lines, this is called a Lewis structure, and this basically shows how the bondings are working. So imagine that there's 2 dots right here, 2 dots right here, and these are the valence electrons, and they're being binded together by these lines, and then we have our 4 others. So another example of a covalent bond is ammonia, and we see here our nitrogen, our hydrogen. Nitrogen has 3, so what we want is to have add 3 more to our 5. So we're going to have 3 hydrogens come in the equation, and this is going to be the bond. So next up we have metallic, and metallic, if you can guess, it's between metals. So what happens is that we have our metal ions, and they're all kind of floating around here, and then we have our electrons, and they're all kind of coming together in this sea of electrons. That's what it's referred to for metallic bonds, and this is responsible for high conductivity, and it makes it really malleable, and it's just perfect for when you want to do these sort of things with metals. So next up, I have a little quiz for you guys. So pause the video and take the quiz, and I will go over the answers in the next slide. So here are the answers, A, C, B. We can and then just right now, I'm just have a little Venn diagram for you guys between our ionic and covalent bonds. So you have to remember that this is formed between a metal and a non-metal where the electrons are transferred, and this is between a non-metal and a non-metal where the electrons are shared. But the overall goal is to get 8 valence electrons. So I hope that this helped you guys in any way, and thank you so much for watching.